My dear little champions, hope all of you are staying healthy and safe at home. Welcome to the world of chemistry through our online learning process, School to Home. Chemistry is not only about learning and recalling, it's about understanding and applying. How you apply your acquired knowledge in your day-to-day life makes the years you spent on your studies fruitful. To help you through this journey, this year also, our education department has set your chemistry textbook in 2 volumes. The first volume consists of 4 chapters and the remaining 3 chapters are included in the second volume. Let us discuss these lessons one by one. As it is a journey, each lesson is related to the previous one and continues to the next one. So dear ones, you should have a thorough knowledge of each and every lesson. Now let us start with the first lesson. Periodic table and electronic configuration. What the title indicates, it's about a table where periodicity is observed and the configuration or arrangement of electrons in an atom. The whole lesson is about the relationship between these two concepts. We have already learned that based on the experiments conducted by scientists, various atom models were proposed, and among them, Bohr's model was generally acceptable and is utilized for giving a lucid explanation to the features of an atom. According to Bohr model, in an atom, electrons are arranged in various shells around the nucleus and they are filled in the increasing order of energy. And as the distance from the nucleus increases, the energy of the electrons in the shells also increases. And the attractive force between the nucleus and the electrons decreases. Now take down these 2 points in your notebook. Let us move on to the pictorial representation of Bohr's model and electronic configuration. Here you can see the electrons are revolving around the nucleus in shells, and these shells can be numbered as 1, 2, 3, etc. or K, L, M, N, etc. And as the distance from the nucleus increases, the energy of the shells also increases. That means L shell possesses more energy as compared to K shell. Likewise, M shell also possesses more energy as compared to L and K shells. If we arrange these shells in the order of increasing order of their energy, it will look like this. And here I am giving you a table containing the maximum number of electrons that each shell can accommodate. This table is familiar to you as we studied this last year also. You take down this table also in your notebook. Okay, now let us write the shell-wise electronic configuration of some elements. Sodium with atomic number 11 and argon with atomic number 18. You complete this table in your notebook. You might have got your table filled like this, isn't it? Now let us analyze that table. How many electrons are present in the M shell, that is the outermost shell of argon? It is 8. Okay. What is the maximum number of electrons that can be accommodated in the M shell? Yes, it is 18. Keep that in mind. And now let us write one more electronic configuration, that is of potassium. Atomic number of potassium is 19. Now you write the electronic configuration of potassium. What you got? Yes, 2, 8, 8, 1. Now compare these two elements, potassium and argon. The outermost shell of argon contains 8 electrons. That is, the M shell of argon contains 8 electrons. Whereas, the outermost shell of potassium contains 1 electron. Even though potassium has 1 electron more than that of argon, that 1 electron goes to the fourth shell instead of occupying the third shell. Remember, the third shell has the capacity to accommodate 10 more electrons. The maximum number of electrons that M shell can accommodate is 18. In the case of potassium, in the M shell of potassium, there are only 8 electrons. It can accommodate 10 more electrons, even though that 1 electron goes to the fourth shell. Why? We know that the studies related to the atomic structure are progressing continuously. Bohr's model is a simple explanation of the atomic structure. Studies related to the nature and position of the electrons in an atom revealed the limitations of Bohr's model and new assumptions were postulated. Accordingly, electrons in each energy level are arranged in its sub-energy levels. There comes a new concept, sub-energy level. Each sub-energy level in a shell is called a subshell. As we called energy levels or shells, we call sub-energy levels or subshells. The shells were named as KLMN. Likewise, subshells also have names. They are named as S, P, D, F. These names are given to subshells based on words indicating certain properties related to the atomic spectra of elements. S is taken from the word sharp, P denotes principal, D diffuse, F fundamental. According to modern theories of atomic structure, electrons revolve in a three-dimensional region around the nucleus. Each main energy level has sub-levels or subshells that we have already discussed. In these subshells, there are regions where there is a high probability of finding electrons. In each subshell, there are regions where there is a high probability of finding electrons. These are known as orbitals. One more new term, orbital. What is an orbital? The regions where there is a high probability of finding electrons. The maximum number of electrons that can be accommodated in an orbital is 2. The S subshell has only one orbital with a spherical shape. The P subshell has 3 orbitals which are dumbbell shaped. The D subshell has 5 orbitals and the F subshell has 7 orbitals. The shapes of D and F subshells are more complex. Now coming back to the relationship between shell and subshell. Each main energy level or shell except K has more than one subshell. The number of subshells in each energy level is equal to its shell number. Listen carefully. The number of subshells in each energy level or shell is equal to its shell number. That is why K has only one subshell, because the shell number of K is 1. K being the first shell. Okay. The next shell L has 2. And the third shell or M shell, how many subshells it will have? Yes, it will have 3 subshells. And in the case of N shell, N is the fourth shell or fourth energy level. So N will have 4 subshells. Now let us tabulate this. Now you go through this table carefully. Which subshell is common to all shells? It is S subshell. From first shell onwards, every shell contains S subshell. And from second shell onwards, every shell contains P subshell. Then, how can you identify the shell in which each subshell belongs to? For this, we give the serial number of the shell to the symbol of the subshell. That is 1S to indicate the S subshell of the first shell, that is K shell, and 2S to represent the S subshell of the second shell, and so on. Then now you complete this table, writing the subshells present in each shell and the representation of these subshells. Your table will be like this. Next we will discuss the maximum number of electrons each subshell can accommodate. For that, we already know the maximum number of electrons each shell can accommodate. That is, K shell can accommodate 2 electrons, L shell can accommodate 8 electrons, M can 18, likewise. Now we will discuss the maximum number of electrons each subshell, that is S subshell, P subshell, D subshell and F subshell can accommodate. For this, we have to recall the concept of orbital. There we studied that one orbital can accommodate only 2 electrons, and S subshell has only 1 orbital. P subshell has 3 orbitals. D has 5 orbitals and F has 7 orbitals. Based on that idea, let us complete this table. Here you write the maximum number of electrons that can be accommodated in each shell in the first row. In the second row, subshells, that is the subshells present in each shell. Below each shell number, you write the subshells which are present in that shell. Below that, we will try to fill the maximum number of electrons that can be accommodated in each subshell. See here, In the first shell, that is shell number 1, maximum number of electrons that can be accommodated in that shell is 2. That is K shell. We already know that K shell has the capacity to accommodate 2 electrons. So the maximum number of electrons that can be accommodated in that shell is 2. How to represent its subshell? It is 1s. Then these 2 electrons should go to that S subshell because K has only one subshell. The shell number of K is 1, so it has only one subshell. The shell number indicates how many subshells a shell will have. So this shell number of K is 1. So it has only one subshell. And the maximum number of electrons that can be accommodated in K shell is 2. So only one subshell and 2 electrons. So where these 2 electrons will be kept? There is only one space, that is only one subshell. These 2 electrons should be kept in that subshell. So from there we get the idea that a subshell can accommodate a maximum of 2 electrons that we have already learned when we were discussing about orbitals. Now move on to the second shell, that is L shell. L shell can accommodate 8 electrons. Okay, L shell can accommodate 8 electrons. Now write the subshells which are present in L shell. Which are the subshells present in L shell? 2s and 2p. We already know that S subshell can accommodate 2 electrons. So keep those 2 electrons in the S subshell of second shell, that is 2s. Then how many electrons are remaining there? That is L shell can accommodate 8 electrons. Among these 8 electrons, we have kept the 2 electrons in S subshell. So how many electrons are remaining? 8 minus 2, 6 electrons. So we should keep these 6 electrons where there is only one subshell remaining, 2p. So we should keep these 6 electrons in 2p. Now move back to the concept of orbital where we discussed the concept of orbital. There we already learned that p subshell can accommodate 6 electrons. Okay. Then move on to the next shell, that is third shell. In the 3s subshell we will keep 2 electrons. In 3p we will keep 6 electrons. As p shell subshell can accommodate 6 electrons, we will write 6 there. And remaining 18 minus 6 plus 2, that is 8. 18 minus 8, that is 10. 18 minus 8 is equal to 10. So we will keep those 10 electrons in 3d. So how many electrons D subshell can accommodate? 10 electrons. Likewise, you find out how many electrons F subshell can accommodate. Okay. You might have got 14. Now let us consolidate this. That is the maximum number of electrons each subshell can accommodate. S can accommodate 2 electrons, P 6, D 10 and F 14. These electrons are filled in shells in the increasing order of their energy. That we will discuss in our next class. Write these questions and their answers in your notebook. Dear ones, hope you understood what we have learned today. Watch this video again and again so that you will have conceptual clarity. Answer the questions given at the end of the class and bring it when you are back to school.